reciprocal functions. Reciprocal functions always represent by a fractions where the top part, which is the numerator, is represented by a constant. Constant means that there's no variable such as 2, 3 or 4 is eventually our constant. Meanwhile, the denominator will be the polynomials. It means that there's a variables or expressions, something like x plus 2, x squared plus 3 and so on. So it means that the unknown is eventually situated at the denominator here. So let me choose 1 as our constant here, and x minus 2 is our polynomial. And this is our example of reciprocal functions. What I'm more curious is about the denominator here. As we know, when we have a fractions, we cannot divide it by 0, or else they will give us the mathematics error. So cannot be 0. So I'm curious about what value of x will give me 0 here. So let us try it out. We say that x minus 2 cannot be 0. So let me transfer the minus 2, go to right hand side, become plus 2. And we find out that x cannot be 2. So we know that this function is not valid when x is equivalent to 2. But you will ask me like, hey, if that's the case, how can we plot a graph? So this is why I want to introduce you that the symbol of approached. Approach means that if we try to choose a number that is very near to 2, but it will never be 2. This is what we call x approaching 2. So let me show to you in a number line where we have 2 is our prohibited area, or we can say it's an asymptote. Asymptote means that we use it in our graph by represent by a vertical dotted line. And this asymptote is a region where they tell us that this functions is not valid in this asymptote. Means that at this line, the function is not valid anymore. So we try to be as close as possible to this line, but we will never touch this region, or we call it an asymptote. So this 2 is our asymptote. So as I mentioned before, you can imagine that this 2 is just like you. You are the pretty girls or the handsome boy in the school. Everybody is going to approach you. Everybody is going after you. So it's always from the left or from the right. So same thing here, our x is going to approach the 2 from the left. How can we represent? We represent by a negative sign. Meanwhile, I think you can guess it. If from the right, we can represent by a positive sign. So this is how we write down the symbols. So let us try to find a number that is from the left hand side approaching. So let's say it's very close to 2, but not yet 2. So we can say that something like 1.6 of the 9th. Very close at 1.99999. And we choose one number from the right hand side that is very close. Maybe something like 2.00001. So those are the two numbers I pick. And try to substitute into the equations and let us find out what would happen now. So if we try to substitute in, then we will realize that these numbers, if you punch in the calculators, you will eventually get something like 1 million, but it's a negative 1. Negative 1 million. So we know that it's a very negative numbers, but if we keep on increasing our accuracy, means that if I put it more numbers, become 1.99999 and 999, so close to 2, the number is going to be approached to 1 billion. If we keep on increasing the decimal places, we are going to be getting more and more bigger number. So this is what happened. We say that we are approaching the negative infinity. Negative infinity means it's a sequence of number that is never ending. It's a sequence that is never end. So we can say that it's a negative infinity. So this is what we have when we pick the number from the left. Meanwhile, if I pick a number that is so close to 2 from the right hand side, let's say it's 2.0001, as you guess, we can get a number something like 1 million. Like just now, when we adding the decimal places, let's say now I'm adding more decimal places, eventually I will get a number like 1 billion, 1 trillion or 1 zillion. So we know this number is never ending. We can say that it's a positive infinity when we approach it from the right hand side. So let me show you in the table form. So those are the values that if we try to approach to 2 closer and closer and closer, you can see that the number is getting bigger and bigger and bigger when we try to approach 2. The more decimal places that we use, the more accurate is our answer. But you realize that it will never approach to exactly 2. So as we can see, when we approach from the left, we have a negative infinity. When we approach from the right, we have the positive infinity. Let us try to sketch our graph now. So the first step is always draw out the asymptote first. Our asymptote here is 2, which represent by a vertical line here. Vertical dotted line, is a vertical dotted line, which we say that this is the region of the prohibited area. So as you can see, we are trying to approach it from the left hand side to the negative infinity, but we are trying to be as close as possible into our asymptote, but we will never touch it. Meanwhile, from the right hand side it's also the same thing. When we try to be as close as possible to the 2, which is our asymptote, we are getting the numbers getting bigger and bigger and bigger. We try to be as close as possible, but we will never touch it. Just like the blue color curve. So this is what we can see in the reciprocal functions. So just a recap, reciprocal functions always represented by a fractions where the numerator is a constant, the denominator is eventually a polynomials. And always remember, we cannot divide by 0. That is the thing that we are curious. So in this case, x cannot be 2, or else this function is not going to be valid. Hey, if you have any questions or would like to see any kind of video, do leave your comments below and let me know. If you want to support us so that we could make more videos like this, the simplest way is just by sharing the video with your friends. Click the like buttons and consider subscribe to this channel. See you in the next video.